Everybody, I just wanted to bring in a little bit of an update for using Excel for ANOVA when you have different sample sizes. In the previous version of Excel, the old version of Excel, you had to have the same sample size to use the ANOVA test function in Excel in the data analysis toolpack. In the newer update, we now can perform tests without having the same sample size. So here what we have is Little Ones Elementary School has 3 third grade classes. And annual standardized testing gives the following math scores. Test at alpha equals 0.05 to see if the classes have about the same mean. So the null hypothesis here is going to be mean 1 equals mean 2 equals mean 3. And of course, we're going to do class, we're not putting teachers' names on, we're just going to label as, A class and B class and C class as their names. We're going to let class A be mu1, class B be mu2, and class C be mu3. And then, of course, the alternative would be at least one class is different. So at least one class has a different mean. And as I said, in the previous version of Excel, we had to have the same sample sizes. But you can see here, Class A has only 20 students, where Class B has 22, and Class C has 21. So if we want to go to data here and open up our data analysis, up to the top, we can click on ANOVA single factor and click OK. And now, if I want to highlight the data labels, I can. So when I click on my data, remember the data still has to be arranged in columns. I'll go ahead and I'll include the data labels, and I'll make sure I drag all the way down to the lowermost one. Notice this one goes down to row 23, so I highlight all the way, I select all the way down to row 23, even though there's no data points in some of those. Grouped by columns, and I am going to click this button here since I highlighted the labels on top, Class A, Class B, Class C. I'm going to highlight that so that Excel knows to ignore that first row of each column. Alpha was 0.05, and then I'll click on output range, and I'll select a spot to show the output right there. And now we'll click OK. And you can see it gives me the same output we've had before. And so this first part is just a summary of the data. Class A has 20 items in it, Class B has 22, and Class C has 21. So I have the correct counts there. The sum of the data, the averages, but for Excel, of course, average means the mean of the data. So Class A had a mean of 78.6, B 78.27, and C is 77. And then the variance for each of those. If you want the square root, you can just, or the square root, if you want the standard deviation, I should say. Just give me a little space there. You can just do the square root of the variance. Click on the right spot there. So you can see the Class A has a standard deviation of 8.37, B is 6.9, and C is 10.8. And then, of course, what we really want for the ANOVA test down here, these are all the values we would get if we did our calculations using those formulas we saw in the previous video. But this is what's important. Our F statistic is 0.191. That's a very small F statistic. Critical F would be 3.15. So remember what that is telling us is the rejection rule would be we will reject the null hypothesis, HO, if F is greater than that critical value of 3.15. Well, since f of 0.191 is not greater than 3.15. We fail to reject the null hypothesis. Also, since the p-value of 0.8270, which is a huge p-value, is not less than alpha of 0.05, that again tells us we fail to reject the null hypothesis. There we go. So you can see what we said there. So this is the simple ANOVA test using Excel when we have different size data sets. Notice again, though, we do still have the data for all of our data sets. If we're given the summary statistics, like just the mean, the standard deviation, and the sample size for each of the sets, then we do still have to go back to that those long, ugly formulas that we saw in the previous video. But there's your update on how to use Excel to do an ANOVA test when our sample sizes are different sizes.